Hi everyone, I will talk about problem 39 combination sum. I think I already have another video regarding this. Um, if you remember, the best way to do that was with memoization, but the issue was, um, I think that's the solution. We had to define something like J, which is not that much uh, intuitive. It's kind of awkward. Then the other issue was when you want to apply it for problem number 40, it's going to get more complicated. So I find that a better solution, this solution can be also applied to number 40 with minor changes. It's going to work. It's as fast as the memoization. So I'm going to apply memoization as oh, um, the other thing is here, first I'm going to start with the base case, and then I'm going to start talking about how we can improve this code. Um, what does it say? So we are start backtracking from current element 0 and okay, target. We are going to say if the target is less or equal than 0, return us just an empty array. Since there is no 0 element here, I think it's one of the conditions. If you don't have equal, then when you get back here, it's going to be less than 0, so it's going to return. So the same thing here. Then what's going to happen? We are going to say if candidate I is equal to target, add it to the response. If not, then we have these two lines. That's the whole logic. I think these three lines are the whole logic. What do we say? So let's say, for example, here we are looking for 2, 3, 6, 7 is the array, the target is 7. We know whatever response we have from previously, if we add it with all responses from these, and if we start with current 0 and I0, so 7 minus 2 is 5. So if we get all the responses from this one, that the target is 5, and then add all this plus basically 2, that is, which is this one, is gonna be the uh, okay, it's gonna be your response here. So here it says candidate I, which is 2 here. It's in, and then this is the all responses from other combinations. What are them? Are okay, we know that we are doing the loop. We are starting from the current position up to the end. So when we are here, we check for first this one, this one, this one, and then this one. Each time we are going to say target minus candidate I, start the backtracking, start from index I. So we start from 3 here. Why I? Because we can have duplicate numbers. If we couldn't have unlimited numbers, if we couldn't have that, then we can add +1, which is going to be another question number 40, which I'm going to cover. Okay, I think the best or the base case is covered here. What are the optimization we can do? One is add memoization, so we can have a dictionary. What we are going to have the dictionary for each current and target, we are going to add them to the dictionary. What do we have here? Let's say when we are doing 2, then we have to do 2, 3, 7, 6. So we are going to do this one once, and then we are going to do this one once, and then this one for different target numbers. But when we are at 3 here, we are going to do 6 and 7 again. When we are at 6, we are going to do 7 again. I like that because each time it's going to get all the way to the end. So if for each current and the target, we get the response, and if we already have it, return it, that's going to be memoization, which is good. The other thing is if we sort it and sort it by reverse, when we hit the case where the target is exceed first, then we are good. We don't need to do the other way, because if we don't, let's say if we start from 7, then and we find out, okay, we are already higher than the target, then we don't need to go 2, 3, 6. But if you start from 2, we are going to do 2, 3, 6, so 6, 7, and that's the best way to do it. So the best way is to do it the reverse. The other thing is, we know if the candidate is more than I, then just pass. So that's going to be the cover that's the best way to solve this equation. It's all natural, it all makes sense. Again, um, we can use number 40, use this backbone for number 40 as well.